So I have planned for around 10 questions today, 10 to 11 questions. We shall see how many of them can we completely solve in the class, and the rest we can, I can give you as homework. Okay. And as per the plan, today's MCQs will be based on functions and calculus. So let us start with our first question, which is based on functions. This MCQ is from NEST 2010. A simple MCQ based on the idea of composite functions. Okay. Let f, g and h be real non-constant polynomials such that f of g of x is equal to g of x into h of x, g of h of x equals h of x into f of x, h of f of x equals f of x into g of x. So these are the three conditions that are given to us. The sum of the degrees of the polynomials f, g and h is 6, 9, 12, not determining. Okay, so this is the problem. The options are 6, 9 and 12, and our job is to see or to find out, if possible, the degrees of the polynomials, rather their sum. And if we arrive at a conclusion that we cannot determine them, then option D should be marked. Okay. Now look, first of all, let us take a note of the fact that these are not just functions, okay, but a special category of functions, and that category is that of polynomials, because only polynomials have a degree associated with them, and that degree is actually the power of the highest power of x. Okay, and they are non-constant, so we cannot assume them to be constant polynomials like x equal to f of x equal to 1, f of x equal to pi, and so on. Okay. Now one thing about these is for sure, okay, let us say our polynomial f of x has the power p. Let's say I'm only talking about the degree now, okay, because when we take the composition, we will now realize that when we will take the composition of f and g, okay, it is enough if we write down the highest power terms of both f and g. The reason being, eventually we are asked to find the degree, and secondly, when we take the composition of f and g, the degree is entirely determined by the degree of f and degree of g. Okay, so although they are set polynomials, we can consider f of x to be x raised to p, we can consider g of x as x raised to q, and we can consider h of x as x raised to r. Okay, there will be other terms, okay, there will be other terms, but some constant, but we will ignore them because we are interested in only the degree. Okay, now can any one of you tell me what would be the degree of FOG, or what would be the expression for FOG, rather, let me ask you that question.
Sir, p plus q.
No, not p plus q. Look here. So we are basically composing f with g, isn't it? So we should be raising x raised to q, which is g, to the power p. Okay, and by the rule of indices, will this not be equal to x raised to pq? It's not multiplication, it's composition. Okay, it's
Yes,
not, yeah,
yes.
वो ध्यान में रखना है. लेफ्ट हैंड साइड में मल्टीप्लिकेशन नहीं है. Got it? It is composition. Okay, so this is now equal to g into h. यहाँ पे multiplication है ना, g into h. Now here the degrees will get added, so x raised to q plus r. Raise your hands if you have understood this part. Great. So now we just have to repeat this pattern. Okay, we just have to repeat this pattern for the other two equations, and then after that we will get three equations containing p, q and r, and let us see if we can get our answer from that. So let us now go to GOH. Okay, अभी GOH में क्या आएगा? Tell me, what will be GOH? H
Q
will
into R power.
uh, x raised to r raised to, correct. So this will be x raised to qr, and on this side it is h into f, hf, so it will be x raised to p plus r. Okay, last one, HOF. Okay, HOF. So f is inner function now, which is p, and yeah, so here we will get x raised to pr, well, the other possibility, and here we have got f into g. F into g we have f into g, so that will be p plus q. Okay, so this part is clear to everyone, right? If you have any doubts, please ask me. इसमें कोई doubt नहीं है ना?
No.
Okay. Now look here. These polynomials, rather, when these polynomials are equal, so what does it tell you? It tells you that x raised to pq is equal to x raised to q plus r. See now, because these are polynomials, we know that p, q, r are natural numbers, right? P, q, r are natural numbers, so we will get equations of the kind p, q equal to q plus r, okay, q, r equal to p plus r, and finally we will get p, r equal to p plus q. Now, can you people tell me, based on this, can you draw any conclusions as far as the values of p, q, r are concerned?
Yes, sir. We can find PQR individually since we have 3 unknowns and 3 equations.
हाँ, लेकिन अभी प्रॉब्लम है कि कैसे, because these are not linear equations, right? You're absolutely correct. You're saying 3 equations are there, eliminate 2 of them and get an equation involving only one unknown. That we can do that. But I just want to draw your attention to the following observation, and that observation is that if, okay, if p is equal to q is equal, there is no harm in assuming this because we are not violating any of the conditions given in the problem. Okay, they're not saying same degree, but they are also not said they're of different degrees, right? So suppose p, q and r are same, then essentially we get only one equation from the family of these three, or from the system, and that equation would be p squared would be 2p. Is it clear?
Yes, sir.
So either p will be 0 or p will be 2, but p can't be 0. Okay, so the sum will be 6. Okay, so the sum will be 6, and that option is A. Okay, so any doubt in this particular step? If p, q and r are assumed to be same or equal, then every equation is going to give us p squared equal to 2p, giving us p equal to 2 or p equal to 0, but p can't be 0 because the polynomials are non-constants. So sum is 6. Any doubt?
No, sir.
Okay. Now I'm going to I'll give you this as homework. You try and see what you get, because Roshan already said that we can solve them. So I'm asking you to eliminate q and r using the equations. Get an equation in p and see if you can solve it. Have you got the point? Just like we do in Gauss elimination method, or the method of reduction as we call it in matrices. Okay, there in every step we try to eliminate multiple unknowns from each equation, right? Let's say if we have x, y, z, from the last equation we eliminate x, y, from the second last we eliminate only x, and then from the first we get x, like a back substitution. Okay, so try that. If you cannot do it, we shall see what needs to be done, but as far as the problem is concerned, we have got the answer, and that answer is 6. Yes. Acha. Now those who are attending my session for the first time, first thing is I stay near airport, so if you hear any noise from my side, or if you don't hear me speaking, it's actually the planes that are taking off. Okay. Secondly, all these things that I am currently writing on my screen, this will be made available to you right after the class. Okay, so my emphasis during the lectures is understand how we are solving the sums. Okay, later on, once you get the notes in the same format, you can access it and write it down. Okay, but my main focus is understand how the problems are being solved. Okay. Okay, so that is question 1 on functions. Let's go to the next sum now. Okay. Now in these exams, they quite often ask sums on quadratic equations. Okay, particularly in JEE, and to some extent in NEST also they ask questions based on quadratic equations. So these could be regarding nature of roots lying in some interval. Okay, or let's say in one of the recent NESTs there was a question like when can they have distinct roots, something like that. Questions based on parabolic trajectories or parabolas, because quadratic function represents parabola, and so on. So here is one such question, slightly different one. Okay, and it is a multiple select question. I know from this year onwards they will not be asking you multiple select questions, but any multiple select question is essentially 4 MCQs put together, because we want to solve, we would like to check for each and every option. Okay, so let us now see if we can solve this question. This is from NEST 2011. Okay, question number 12 from the paper. Consider the equation x squared plus bx plus c equal to 0, where b and c are integers. Suppose it has an integer solution p. Okay, suppose it has an integer solution p, or root, one of the roots is p. Then option A, p is odd if c is odd. Option B, c is odd if p is odd. Option C, b plus c is odd if p is odd. Option D, b is even if b plus c is even. Okay, now because you can see the options odd, even, this question is also based on parity. Okay, parity is basically the property which classifies the numbers into, or integers into, odd numbers and even numbers. Okay, so I want you people to try this MCQ out. I will tell you the things that you need to solve this particular problem. Okay, firstly assume that the other root is q. Okay, firstly assume that the other root is q. So what will be p plus q? P plus q would be c, and pq would be negative p. Okay, and because c is integer, p is integer, and addition of integers is a closed operation on the set of integers, so q should also be an integer. Second thing is that even plus even is even, odd plus odd even, even plus odd odd, even into even even, even into odd, sorry, let me first write odd into odd, sorry, odd into odd odd, no matter what the sign of the number is, and even into odd is even. Okay, these are all, this is what you need to solve this particular problem. I'll give you some time, maybe 5 minutes, to solve the problem, and then If you have any difficulties, then I will solve it for you here. ठीक है, start. अगर कोई solution दिमाग में आ रहा है तो बताओ. You have to go option wise. So pick A, read it what it is telling, start from what is given, see if you can arrive at the conclusion. And you can write down this MCQ number, okay, so that later on you'll understand which MCQ you have solved.
So shouldn't say give a product of fruits.
Oh yeah, sorry, my bad. Sum of fruits is minus b, my bad, sorry. And PQ is, sorry. Yeah, well, I was going to write, I meant the same thing, but by mistake I did not write it correctly. Okay, what do you think of option A? Shreyas, what do you think of option A? Among the 6 things we have written here, which one applies to option A?
So we'll have to look for the product of fruits then.
Exactly. C is odd. C is odd. C is product. So it's this. So without any hesitation, can we say that option A is correct? If the product of two roots is, or two numbers, two integers is odd, okay, then obviously both of them must be odd, because we cannot have one odd and one even integer whose product is still an odd number. So what can you say about option A? Is option A correct? Yes, it is correct. Okay, I'm also writing down it here, the fact that we have used to prove option A. Correct. Yes, have others understood why option A is correct?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
great. Acha. Go to B then. Go to B. C is odd if P is odd. Now in this option, it is given that P is odd. Okay, but they're saying C is odd. Now see, it may be true in some cases, but when we are selecting it as a correct option, we need to make sure that no other case exists which contradicts the claim in that particular option. So if we consider a combination like this, we are not putting any restriction on Q. Okay, so if we let this to be our P, and if we let our other root to be an even number or even integer, what can we see regarding the product? The product is even. Okay, so that immediately rules out option B. Understood?
Yes, sir.
Yes, sir.
है ना? P पहले में कैसा था? C ही odd था, तो एक ही possibility थी. P odd में दो possibilities है. P can be P odd Q even or P odd Q odd. But as I said earlier, if you are selecting anything, then the hypothesis there has to be true for all cases. Okay, no exceptions. So B is not right. Now let's go to C. Let us go to C. If P is odd, B plus C is odd. Okay, so here we are considering P to be odd. Okay, if P is odd, matlab P odd is given. Now look, we need to consider two possibilities here. Okay, possibility 1, P odd, Q odd. Okay, if we consider both P and Q to be odd, what can we say about the product? Product will be odd. Okay, product will be odd. What will be the sum? Sum will also, oh, sum will not be odd, sorry, sum will be even. Odd plus odd is even. Now, it is to be noted here that even if we multiply this thing by -1, that will still be even. Do you agree? By changing the sign of the number, the parity remains unchanged. है ना, 2 को -1 से मल्टीप्लाई किया -2 है, वो भी इवन ही है. ठीक है. So when both are odd, what can we say about B plus C? Look, if PQ is odd, then P and Q are odd, then PQ, the product, is odd, so C odd हो गया. P plus Q is even, so minus this will also be even. So what can we say about B plus C? Even plus odd. Would it be even or odd? It would be odd. But don't hurriedly mark option C because we are yet to consider another possibility. कौन सा possibility है वो? Which possibility have we not yet considered? Sorry?
Even.
Q is even, correct. Q even का possibility नहीं consider किया. We have to do that. Now what can be said about PQ? Product.
It will be even.
It will be even. How about P plus Q, the sum? Sum will be odd. Will multiplying it by -1 change anything? No. No, correct. तो अभी ये ऐड कर दो, even plus odd, again odd. See, that means we considered both the possibilities for Q, but we still got the conclusion that even plus odd is odd. So eventually B plus C will always be odd if P is odd. Okay, it doesn't matter what about the parity of the other root. So excuse me. So C is correct. Okay, C is correct. Now can you try option D? B is even if B plus C is even.
So B is incorrect.
D is incorrect. How?
Yes, sir. So because it won't be true in all the cases because B can be even if P is odd.
Can you give me an example?
So the case where both P and Q are odd, in that case B will be even, but as we just proved, P plus C will always be odd regardless of the sign of
Okay. No, here we have B. Okay, P is not there anywhere here. Got it.
P. So but B plus C will always be odd.
No. See, in option C, if P is odd, then B plus C is odd. Which means when can B plus C be even? B plus C can be even in only one possibility where both P and Q are even. Is it clear? See, look here.
Got it, sir?
Got it? देखो. It is given that B plus C is even. Now, what does it mean B plus C is even? B plus C is even means B odd, C odd, or B even, C even. Okay. Now, if we consider the possibility of C being odd, okay, if we consider the possibility of C being odd, so we have to again go back to this one. है ना? We have to go back to that, which means both P and Q are odd. Therefore P plus Q will be even, है ना? Odd plus odd is even. Odd plus, oh sorry, यहाँ पे option D लिखना चाहिए था, sorry. Odd plus odd is even, but what is claim in B, or what is the claim that we have made? But B is odd, so this possibility doesn't exist. So will the other possibility be there? Yeah, of course it has to be there, right? तो C even में भी अभी एक possibility क्या है? Okay, let's just investigate for it. C even, P Q both even, no question of P plus Q being odd. Okay, so now suppose we get P odd, or let's say 1 even 1 odd. Okay, 1 even 1 odd. What can we say about P plus Q? P plus Q odd is impossible. Sorry, P plus Q is odd. Okay, wait, P1 Q odd हो गया, P plus Q has to be odd. What about PQ? PQ will be even. Okay, P plus Q odd. Now see, this possibility is won't be there. Okay, this possibility won't be there if we consider P even Q odd. Okay, for the product to be even, the sum must be odd. Okay, wait, we need to think now about this, because we are getting some cases which we didn't think will pop up. B plus C even है तो B हमेशा even होना चाहिए. If B plus C is even, B odd C odd, or B even C even. B odd C odd means PQ. Okay, C odd means P and Q odd, which means P plus Q has to be even, but B is odd, so this can't be true. Okay, B even C even. Let us consider the possibility that both P and Q are even. P plus Q will be even, so B will be even. Then P even Q odd. Third possibility, P plus Q is odd. Okay, wait. So let us consider the possibility of P and Q being odd. Okay, so let's consider P2. Let's consider sorry, P3. Let's consider P3, and let's consider Q as 5. Both are odd. What will be the sum? Sum is 8. Okay, which means if both are odd, the sum will always be even. Okay, now let's consider this possibility. PQ even. Okay, PQ even, P2 Q4, P plus Q will be always 6. Let's consider 1 even, 1 odd. Okay, P plus Q will be 5, PQ will be 6. Yes.
So why are you considering the third possibility, since the basic requirement of the option is that P plus Q should be even?
No, P plus Q plus PQ is even. Yeah, I got it now, because one is odd. Yes, correct. इसका ज़रूरत नहीं है क्योंकि P plus C है. ठीक है, so in either of the cases we have got the conclusion that P plus Q has to be even, right? PQ8, P plus Q8, P plus Q6. So option D is correct. Okay, so A is correct. How about C? C is right. D is also right. अच्छा, as far as option D is concerned, do you people have any queries regarding that?
So can you show option D again?
D,
Like,
yeah. See, because see, okay.
so
Additionally,
in the first case that we took, didn't we disapprove option D?
how?
Because in this case, B plus C is even, but B is odd.
No. Oh, okay. B plus C is even, which means B odd, C odd. P, Q both are odd. Okay. Therefore, P plus Q is. Oh yeah, you're right. B odd है और C भी odd है, तो P Q दोनों odd हो गए. P Q both became odd. Therefore, P plus Q is even, but P is odd. Okay. See, my main point is B plus C even in this case? P plus C, it's not even, right?
Yes, so we only took the cases where B plus C will be even. So
No,
we
no,
took
no,
the
no, no. Wait, wait,
cases
wait,
B
wait, wait.
and C are both odd.
Yeah, yeah. See, if suppose we take, see, look. Okay, okay. Got your point. First of all, realize that only these three possibilities exist. The roots being both odd, both even, or one even, one odd. Is it clear? Yes.
Yes, sir.
So in this case, for even there is there is no issue. So you agree that when B plus C is even, B has to be even, क्योंकि दोनों even ही हो जाएंगे.
Yes.
Okay. Now let us consider the odd case. Now that odd case is what I considered here. Okay.
So
Let me first complete, and then if you have any queries you can ask. Okay. So if both are odd, okay, if both are odd, what can be said about B plus C? B plus C will be odd, है ना?
yes, sir.
Now see, this is actually not meeting the very requirement given in the problem, so we have to discard this possibility. That cross is meant for that. Is it clear?
So we have taken P and Q. The
So what?
question is B plus C is even.
So when can B plus C be even? Please tell me.
B plus C will be even
Huh.
in this case.
But when do you agree that B plus C will be even when both will have the same parity? Right. But please note that at the very heart of it, we still have only these three possibilities, which basically exhausts the list. है ना? Or you didn't get it? See, look. हमारा जो ओरिजिनल क्वाड्रेटिक इक्वेशन है, उसमें आप ये तो अग्री करते हो ना कि P और Q दोनों इंटीजर्स ही रहेंगे? Yes.
Yes, sir.
So do you now agree that then we will have only three possibilities for them? Both will be even, both will be odd, or one even and one odd. Correct?
Yes, sir.
Huh. Now I'm talking about roots, okay, not B and C. Now please tell me, when both roots are even, okay, when both roots are even, will B plus C be even? Yes. But in that case, will B also be even? वो तो रहेगा ही. So the possibility that both roots are even, that is now being covered. Now go to the possibility where both roots are odd. Now when we consider both roots being odd, उसका मतलब क्या है? Both roots are odd. It means B plus C is odd. क्यों? Because B considers the sum, which is even number. Q considers the product, which is an odd number, which means B plus C. मतलब इसमें ये रिक्वायरमेंट ही फुलफिल नहीं हो रही है, इसीलिए ये पॉसिबिलिटी रूल आउट करनी चाहिए, क्योंकि गिवन है B plus C इवन होना चाहिए. इज दैट क्लियर?
Yes, sir.
Got it? Now let us consider the third one, one even and one odd. Now in this case, can you tell me the sign of a parity of B plus C? एक even एक odd में. Tell me, if one root is even and the other root is odd, then what is going to be the parity of B plus C? वो odd होगा या even होगा? Product will be even. Exactly. That means in this case also we don't want, or rather we are not getting B plus C even, तो उसके आगे का जो conclusion है वो नहीं निकाल सकते. Which means we then it gets boiled down to only one fact or one possibility, and that possibility is दोनों P Q even है. Got it? And now when both P and Q are even, then B plus C, if that is even, then B is automatically. Is it clear?
Yes, sir.
Yes, sir.
Okay? Yes. Fine. So that's it about this question 2. Others, if you have any doubts regarding option D or the entire question, please ask me by raising your hands. Otherwise, we will go to next question. ये समझा है ना सबको?
Yes, sir.
Okay. Third. This is from Nest 15. A slightly mixed concepts MCQ. And if you people have studied reasoning in 11th standard, or in some textbooks they call it mathematical logic, and in particular the truth table, okay, 1 0 or TF, this question will be easier for you. Let X be a non-empty set and let P of X be the set of all subsets of X, also known as power set. Define a function f from the Cartesian product of X with its power set to the set 0 1 such that for X belonging to X and capital A belonging to capital A a subset of X, okay, f of X comma A is 1 if X belongs to A, it is equal to 0 if X does not belong to A. Then for X belonging to X and AB being subsets of X, f of X comma A intersection B is not equal to option A, f of X comma A into f of X comma B, option B, f of X comma A union B minus mod of f of X comma A minus f of X comma B, option C, f of X comma A complement plus f of X comma B complement minus f of X comma A complement union B complement, option D, f of X comma A plus f of X comma B minus f of X A union B. Okay, so we are basically given a set, it's non-empty, and we are also given its power set. Okay, so this contains elements, this contains sets, right? P of X. We are defining a function, okay, we are defining a function f, okay, from the Cartesian product, means the first element will come from here, it will be an element, second element will come from here, which will be basically a subset of X, okay, which will be a subset of X, 2 0 1. Now this function is easier to understand. If that element that you have chosen from X, if that also belongs to the set that you chose, then the value of the function will be 1, otherwise the value of the function will be 0. Raise your hands if you have understood what this function tells you. Others, have you understood this? What the function tells you? Okay. Now look, we want to find out the value of the function f of X comma A intersection B. Now please tell me, when will it be equal to 1? This will be equal to 1 when X belongs to A and X belongs to B. दोनों में होना चाहिए, इंटरसेक्शन है. रेज योर हैंड्स इफ यू गेट दैट. In all other cases, how many cases are left? 3 cases are left. Belongs to A, does not belong to B. Okay, does not belong to A, belongs to B. Third case, does not belong to A, also does not belong to B. है ना? Okay. Now let us go to option A. Option A says f of x into a, f of x comma a into f of x comma b. Now see, look here. If we want our x to belong to a intersection b, okay, if we want our x to belong to a intersection b, it must be in A as well as in B. In all other cases it will be 0. Meaning, मान के चलो x A में है लेकिन B में नहीं है. Okay? So I am basically covering these two possibilities together now. Because this operation is commutative regard the intersection operation, we can only consider one possibility and get rid of the other. ठीक है? So if x belongs to A but doesn't belong to B, then this will become 1, this will become 0. But that automatically makes f of x comma a intersection b 0, because it doesn't belong to a intersection b. Is this clear what I am saying? Look. If we consider 2 possibilities out of 4, which 2 possibilities are we considering? This one. है ना? Suppose we consider these possibilities. This means f of x comma a, let's say it is 1, f of x comma b, suppose it is 0, then obviously f of x comma a intersection b will be 0, क्योंकि वो एक में नहीं होगा तो दूसरे intersection में कैसे होगा? Okay, have you understood this? So
Yes, sir.
so that works for these 2 possibilities. Now does it work for third possibility also? Yes, it also works for this possibility. Because if it does not belong to at least 1, then obviously it won't belong to intersection. Okay? And how about when it belongs to both? Yes, that's true. Okay? When it belongs to both of them, then obviously it has to be 1, right? If it belongs to A, if it also belongs to B, let's say if it also belongs to B, then can we say that it belongs to A intersection B? Of course, that's the conclusion. है ना? तो option A में जो लिखा है वो सही है. They are saying is not equal to. So we cannot say, we cannot mark option A. Also read the problem carefully. It is not equal to this. In this case, it is equal to this. So we cannot say that. ठीक है? अच्छा. Now this actually implements the AND gate. Okay, when both are 1, only then it will be 1. Otherwise it will be 0. ठीक है? अच्छा. अभी हम बचे हुए options की बात करेंगे because we have not yet got the correct option. Okay, because we have not yet got the correct option. Okay. Now please tell me, what do you think about option B? Okay, what do you think about option B? Do you think option B is correct? Do you think option B is incorrect? Please tell me. Yes, please. Now I am indicating by ones that it belongs to A. Come on, tell me. See, basically what you have to do is you have to now algebraically add or do the operations here and see if you are getting that. Okay. Now let us start with the first possibility, where it belongs to both. Okay, so this will be 1. Are we getting the same answer? F of x a union b minus mod of 1 minus 1, है ना? Are we getting 1? Yes. इसमें चले जाओ, दूसरे रो में जाओ. F of x a union b 1. Okay, x comma a 1 है. Okay, x comma a is 1, x comma b is what? 0. We are getting 0. Okay, तो इसमें भी आ ही जाएगा वो. Okay, same thing here, because it's mod. Okay, now how about this? Of course, this will be satisfied. So option B is also right. Now at least I did not expect truth tables, use of truth tables at this particular sum. Okay, because it is purely based on set theory or functions. Got it? So what do you think? Option B, whatever statement they have made is correct. But can we then mark option B? No, we cannot. Why? Because we want the incorrect one, not equal to. ठीक है, अभी हम D की बात करेंगे. D की बात करेंगे क्योंकि D में कॉम्प्लीमेंट्स नहीं है ना? D में कॉम्प्लीमेंट नहीं है, तो D की बात करेंगे. अच्छा. Now you people tell me. Okay, you people tell me how can D be handled? Okay, how can D be handled? Let us again prepare this truth table here. Yes, tell me. Let's go to first one. Okay, x comma a plus x comma b minus x comma a union b. X comma a plus x comma b minus a union b 1 आ रहा है. Second, x comma a plus x comma b minus a union b.
So we won't mark D.
Yes, yeah, I just realized that वो भी वही दे रहा है हमें जो correct. So which option is right? Option C is right. मतलब D सही है, as in we can use an alternate way to find f of x comma a intersection b. So which option is right? C is right. Please raise your hands if you have understood this. ठीक है, so see, the purpose of solving these MCQs, of course, it is to check how much of the content we have understood, and secondly how much we can apply. But the thing about such MCQs is they teach you to be ready for any question that is posed in front of you. If you stick to some patterned MCQs, if a new MCQ comes or a new situation comes, there might be a bit of hesitation in attempting that. Okay, so please be ready for any concept, any MCQ which you have never seen before, the concepts which are combined. Like for example, in that recent IIT question paper, there was a vertical circular motion MCQ in physics, and it was the entire assembly was dipped in water. Okay, so there we study buoyancy and circular motion independently, but we never study them together. वैसे situations के लिए maths में भी ready रहो, जैसे अभी ये था. We didn't expect truth table. I mean, there could be other ways also, but my way was just to build a truth table and get the options. A में भी कर सकते थे वो, लेकिन वो मैंने आपको अलग तरीके से करके दिखाया. मतलब हर एक possibility लिख के, had we written a truth table for A, we would have got it soon. ठीक है? अच्छा, तो क्वेश्चन 3 में कोई डाउट है क्या? एनी डाउट इन क्वेश्चन 3? अदर्स?
No, sir.
Newly joined students, Deepanjan, Nabil, Navya, Gaurav, you people, the others are already familiar with the way we conduct sessions, but you people please be active. Okay, if you have not understood, please ask me. ठीक है? Yeah.
Yes, sir.
Okay. Now let us go to question 4. Continuity question from nest 17. Let the function f from R to R be defined as f of x equal to box x, where for any real number t, box t denotes greatest integer not exceeding t. Then f is continuous at. pi by 2 pi 3 pi by 2 2. ठीक है. Now look,
Sir, is it C?
have you solved this before?
I've seen the video for this, so
Okay.
I kind of.
Yeah, okay. Okay. Others who are not aware of this MCQ, first of all you have to draw the graph
Sir,
of sin x.
sir, yes, sir.
See here, no? See, this is the graph of sin x. Now, see, the reason why I have drawn it only from this is because of the options. Okay, because of the options. Okay. Now I want to plot the box x function for this. Box of this. Okay, so please tell me, what would be the values of the given function from 0 to pi by 2? Do you agree that for these, all of these, it would be 0?
Yes, sir.
Yes.
Yes, sir.
कहाँ पर चेंज होगा?
Pi by
pi
2.
Pi
by
by
2
2.
1 होगा.
Exactly, and then again from pi by 2 to pi,
Pi by 2.
0 रहेगा, 0 रहेगा. तो discontinuity at pi by 2 ये तो चला गया. Okay, next one. Now go from pi to 3 pi by 2. Okay, greatest integer less than or equal to that. Now look, here sign is negative, so the greatest integer has to be what?
-1.
हाँ, -1 है, करेक्ट. तो यहाँ से यहाँ तक, यहाँ पे कंटिन्यूस है वो, मतलब लेफ्ट से. And how about 3 pi by 2 to 2 pi? The values of the sign are still negative and they're approaching 0. But for greatest integer, it has to be like this. And for 2 pi, it will again jump to 0. ठीक है? So which is continuity, point of continuity? 3 pi by 2. Correct. Do you think other points of continuity will also exist for this function? As in,
Yes, sir.
Yes, sir. Since it is a periodic function. Other
acha, great. See, that means if we take an interval, let us say a closed interval 0 to 2 pi, let us suppose closed interval I have taken, closed interval 0. Okay, let's better take open interval. How many discontinuities can it have? Don't worry about the endpoints now. How many discontinuities are there?
2.
Pi by 2 and pi. Yes, 2 discontinuities per interval, per open interval. Okay. See, now they can also ask you questions like, what is the longest continuous interval? Okay, so what is the longest continuous interval here? It would be
pi by
Pi.
pi to pi.
open interval pi
Pi
to,
to 2 pi.
exactly, 2 pi. Yes, longest continuous interval. मतलब वही क्वेश्चन सिर्फ अलग कंक्लूजन्स पूछ सकते. ठीक है, fairly simple question. अच्छा, so this is a derivative question. Let f from R to R be defined by f of x equal to box x plus root x minus box x, same greatest integer function. Okay, and root y is the positive square root. Okay, positive square root for y. Option A, it is differentiable everywhere. Option B, continuous everywhere. Bijective, discontinuous only at integer points. ये होमवर्क के लिए दिया तो चलेगा क्या?
Yes.
ठीक है, please try that. If you cannot solve it, I will send you the solution. But please note that this question is based on shifting of graphs. Now, what do I mean by that? Let me explain this part only. Okay. Look, suppose this is graph of f of x. Okay. Let's say this is graph of f of x. Now, if I want to plot the graph of f of x plus a. Okay, if I want to plot the graph of f of x plus a, it will shift a bit upwards. Okay, so wait, let me explain it on Desmos here, it will be clearer. अच्छा, तो कोई भी ग्राफ ले लो. ओके, कोई भी ग्राफ ले लो और इस ग्राफ में कोई नंबर ऐड करो. Okay, so see what is going to happen is this graph will shift upwards if a is positive. Okay, wait, to explain it better, let us restrict x from -1 to 1. Yeah, now we'll have a better vision. See, if we are adding a number to the original function, okay, depending on the sign the graph will shift, okay, along vertical axis. ठीक है. Now one very important thing, suppose you bring that change in x. Okay, suppose you bring that change in x, but this time अभी ये वेव की तरह है, फिजिक्स में जो हम वेव मोशन पढ़ते हैं ना उसके तरह. If instead of x, if we take x minus a, okay, and instead of sin x, if we take sin x minus a, okay, then the graph will actually shift. Okay, the graph will actually shift. How? Wait. Yeah, sorry. Yeah, it's not plotting. See, look, if I change this one, okay, let me hide this, you can see the graph shifting to right and left. Okay, so if a is positive, okay, if a is positive and if you replace x by x minus a, the graph shifts to the right. Okay, then the graph shifts to the right. And if you have negative a and if you still have x minus a there, then the graph shifts to the left. Okay, then the graph shifts to the left. Now where can this be used for us? Okay, where can this be used in this problem? Let me first okay, f of x plus a shift along y, and if we have f of x minus a, shift along x. Okay, now this will be useful in plotting the graph of this function. Okay, this will be useful in plotting box x, क्योंकि box x तो सबको पता है, plus root of x minus box x. You'll get some very interesting results. Okay, if you successfully manage to plot this particular function graph. Desmos पे plot मत करो, क्योंकि एक बार वो दिख गया ना, फिर उसका जो originality है वो चला जाएगा. When once you look at the graph, then everything will be clear. ठीक है, try this at home. Else I will send you the solution by today evening. ठीक है? Okay.
Could this also be done by limits?
Yes, you can do that. No problem. Okay, let's move on. Yeah, this is one of the standard types. This is from nest 20 shift 1. Let f from -1 to 1 to r be a function such that magnitude of f of x is less than or equal to x squared. Okay, for all x in that interval. Then f dash of 0 exists and negative, f dash of 0 does not exist, f dash of 0 exists and equal to 0, d f dash of 0 exists and positive. Now if you remember, there is another problem which we have solved in which they say mod of sin x minus sin y less than something. ये उसी के कैटेगरी में है. Okay, so there is a trick, not exactly a trick, but there is a standard approach using which we can solve all these problems. Okay. First of all, we need to decide whether this function is differentiable or not at 0. Okay, and secondly, if it is differentiable, then we need to find the value. Okay, so how to find that? Observation 1. Look, mod of f of x is less than or equal to x squared. So what can be said about mod of f of 0? Less than or equal to 0. But mod can never be negative, isn't it? Mod can never be negative. So mod of f of 0 must be equal to 0. Therefore f of 0 is 0. Please raise your hands if you understand this part. Great. Now first principles. F dash of 0 निकालना है. F dash of 0 is to be found out. Write down the definition. Lim h tends to 0, f of 0 plus h minus f of 0. You will now realize why we found f of 0 first upon h. है ना? So what would it be now? F of h upon h. Okay, f of h upon h. Now you invoke the inequality again. Mod of f of x is less than or equal to x squared. Okay, now by invoking the inequality, what do we get? F of x is in between minus x squared and x squared. है ना? So minus h squared to h squared. Okay, it will be bounded by that. Okay, I hope you understood this. हम अभी इसको use कर रहे हैं. ठीक है, part 3. Now you might ask the question, what if h is positive, h is negative? We are not considering those cases, but eventually it will boil down to the same set of inequalities. ठीक है, because the limits are 0. ठीक है, so let's divide by h. So you'll get minus h. Apply sandwich theorem. Limit as h tends to 0, f of h by h equals limit h tends to 0 plus or minus h, which is 0. Therefore f dash of 0 is 0. See. Is it clear, or shall I explain it again? When the function's definition is not given, rather some inequality is presented, okay, it is better to first find out the value of the function at 0, और वो हमेशा 0 तक ही पूछेंगे. Okay, जब mod दिया है तो हमेशा 0 का ही पूछेंगे वो. तो first step is we find that f of 0 equal to 0. Then we go to the first principle and then we find out the derivative at 0. Again use the inequality to solve the problem. Any doubt on this?
No, sir.
No?
No, sir.
Oh. Acha. Now let us solve this problem. Let a and b be non-negative real numbers. Non-negative real numbers satisfying a squared plus b squared is 4. Now if they satisfy a squared plus b squared equal to 4 and non-negative, but 0 can't be there now, so we can conclude that a positive, b positive. Then the minimum value of 4 raised to a plus 4 raised to b is 2 raised to 1 minus 2 root 2, 2 raised to 1 plus 2 root 2, 2 raised to 1 minus 1 upon root 2, 2 raised to 2 root 2 minus 1. Now I want to tell you a few things about this particular problem. This problem belongs to the category of problems which are called as constrained optimization problems. Okay, now what is meant by constraint optimization? By constraint optimization, we mean the function that we want to optimize. Okay, now see, look, we can choose values of a and b at our will so that the function is minimized or maximized, whatever it is. But we would like to meet that requirement under a constraint. So when it is a squared plus, under this constraint, if you see, then it is called constraint optimization. है ना? Got it? Then it is called constraint optimization because we are imposing a condition there. कंडीशन दी है प्रॉब्लम में, वो अप्लाई करके ही प्रॉब्लम सॉल्व करना है. ठीक है. First point that I wanted to tell you about this. Second point is that the moment we see a maximum or minimum value finding problem, the first thing that comes to our head is applications of derivatives. Correct? The first thing that comes to our head is applications of derivatives. So what I'll do is I will bring this change in variables, only the notation, so that we get more familiar with the problem, rather the problem becomes more familiar to us. Okay. So we would like to find the value of, let us call it s now, the sum 4 raised to x plus 4 raised to y under the condition x squared plus y squared equals 4. Right? So our standard process is eliminate y. It is given non-negative, so positive root ही आएगा. And then we get this function as 4 raised to x plus 4 raised to root 4 minus x squared. Raise your hands if you have understood till this. Now if you want to find the minimum value, what would you do? You would first take the derivative, equate it to 0, solve. Okay, you'll get the roots. Okay, or x values. Then you go for d2x by dx squared. Okay, and then you find the minimum, or for the minimum this should be positive. है ना? कर सकते हैं. But you will soon realize the moment you find ds by dx that it is so time consuming and lengthy. Answer आएगा. Okay, answer आएगा. But it will take you a lot of time. Okay, the main culprit is this function. 4 raised to तो है ही, उसमें root भी है. Okay, so a bit tricky. And see, the reason why I am telling you this, if you think an approach is not working in some problem, start thinking of new ways. That's the main thing. Okay, every time our standard approach will not work. Might work, rather will work, but it's time consuming. You can try. So then we look for something, okay, then we look for something which can give us the solution easily or quickly rather. Yes.
Sir, we will test for optimality by taking different values of a and b satisfying the constraint. That's the only option which I have.
हाँ, वो भी कर सकते हैं.
Because a square plus b square equals 4 and a and b are positive, so we'll take different values and then we will test for optimality.
हाँ, लेकिन उसमें क्या है, you will never be sure about it. I got your point. I think most of us will actually go for it. Pick two values AB. Okay, pick two values AB which meet the requirement a squared plus b squared equal to 4 and put that. But I have a slightly different variety, and you'll immediately understand it the moment I use it. Okay. So this is based on AMGM inequality. Remember in one of our problems earlier, which the same problem got repeated in this IISc exam, and it was also there in NEST. Do you remember solving that problem? ये उसी लीग का है, उसी लीग का problem है. Look, AMGM inequality. This says x plus y less than 2 by 2 is greater than or equal to root xy. which also means that x plus y by 2 minimum will be root xy when x equals y, both are positive. Is this part clear? Yes?
Yes, sir.
हाँ, तो अभी ये समझ में आ गया ना, we have a definite idea कि भाई अभी क्या करना है. Look here now, we want to minimize 4a plus 4b, है ना. तो इसका मिनिमम वैल्यू निकालने के लिए सबसे पहले इसका मिनिमम वैल्यू निकालो. Do you agree that this will be equal to root of 4a into 4b? Please raise your hands. Yes, so अभी तो काम हो गया. Therefore 4 raised to a plus 4 raised to b min will be 2 times root of 4 raised to a into 4 raised to b. But still we haven't considered one possibility, or rather one information, and that information is that the arithmetic mean will be equal to geometric mean only when x and y are same. So if a and b are equal, or a and b must be equal, right? Also, for this a must be equal to b. अभी हो गया हमारा काम. If a is equal to b, we have not justified it, okay? We have not randomly taken a equal to b. You may still say कि मैं इसको a b ले लेता हूँ equal, मेरा आंसर आ जाएगा. It will not always be guaranteed that it will give you the minimum value. It will give you optimum value, but not maximum or not minimum. We don't know. ठीक है? Fine. So if a is equal to b, what does it give? A square 2a squared equals 4, a squared equals 2, a equals root 2, so is b. Okay, so you got the value now. Therefore we get 4 raised to root 2 plus 4 raised to root 2, which is 2 times 4 raised to root 2. So it will be 2 raised to 2 root 2, 2 raised to 2 root 2 plus 1. Option B. Any thing that you haven't understood in this problem? Especially for minimum, you also keep AMGM inequality in your mind. Yes, you also need to keep AMGM inequality in your mind. Otherwise, if you go for this calculus approach, there is nothing wrong there. Okay, I'm not saying this approach will not work. The thing is, you don't have that much computational support in the paper or while writing this in the exam. Exam environment is important now. Solving these problems from multiple approaches is a very good thing. In fact, that is what you are likely to do next, okay, when you enter colleges. But for the exam, entrance exam point of view, AMGM inequality is way better than our second approach. ठीक है? Done? Okay, that is question 7. Now let's go to question 8. Okay, please try this question now. It's very simple. From NEST 2011, question 8. The value of the integral 0 to 1 e raised to x squared dx lies in the interval e to e squared to infinity 1 to e 1 upon e to 1. कैसे करोगे?
So, can we try and comparing it with e to the power x?
Yeah, you can, but there is even a better approach for that.
We can take
Yes,
we get the value at x equals 0 and 1.
Sir,
correct.
Then we take the area, it'll be between 1 and e at the.
Yeah, but you have to provide an explanation for that. You say e raised to x squared is an increasing function. है ना?
Yeah.
Yep. It's easy to say that. Okay, for 0 to 1, uh, this derivative is always positive, so increase. Now what you said will be valid. Okay, also mute yourself when not speaking. Okay, so increasing, which means, अच्छा, now let us find out the value of the function at 0. कितना है f of 0? F of 0 is 1, f of 1 is e. ठीक है? So see if we go for the graph, this is 0, this is 1. Okay, this is the lower line 1, and this is the upper line. So the graph will be somewhere in between the two. Okay, we will later on plot it on Desmos also. And see, it is even function, e raised to x, right? So ऐसा ही रहेगा. We will see that. Okay, but the point is because we want to find this area, okay, because we want to find this area, इंटीग्रल है ना, तो एरिया हो जाएगा क्योंकि ग्राफ एक्स एक्सिस के ऊपर है. So this area will be shaded area will be greater than 1 because 1 is this, है ना, square का, but less than e. E will be what? This whole area. Please raise your hands if you are understanding what I just said and what Nabil said. Correct? So you can use this inequality to solve this particular question. So what is the right answer? Greater than 1, less than e. Greater than 1, less than e, option C. Okay, greater than 1, less than e, option C. Now they can also complicate things. They can also complicate things by giving you this one, -1 to 1 e raised to x square. तो जिसकी अभी मैं बात कर रहा था कि फंक्शन इवन है, वो अभी आपके काम आएगा. So the range of this would be 2 to 2e, है ना, 2 to 2e. Let's not plot it. इवन है क्योंकि इवन पावर्स ऑफ एक्स है तो वो इवन ही रहेगा. ओके, लेट्स नाउ फाइंड इट्स अप्रोक्सीमेट वैल्यू. 1.46 है, 1 ई की वैल्यू 2.718 है, तो इन दोनों के बीच में है वो. ठीक है, सो गो टू -1 नाउ. It's 2.92, greater than 2, 2e is 5.43, so less than that. ठीक है, got it? That's how this problem is meant to be solved. अच्छा, any doubt here?
No, sir.
No, sir.
Okay. Okay, question 9. If integral 0 to x f of t dt is x plus integral x to 1 f of t dt, then the value of f of 1 is 1 upon 2, 0, 1, minus 1 upon 2. I'm giving you this as homework, but I will tell you how to solve the problem. The hint is use differentiation under integral sign. Or what you call as Leibniz rule. है ना, दोनों साइड का डेरिवेटिव ले लो, you will get the answer. Okay, take the derivative on both sides to get the answer. ठीक है?
What is it?
Yes.
Is it 1/2?
I I don't know the answer. Could be 1 by 2. Did you try that?
Yeah.
Okay. So Nabil has got option A. I'll just mark it here. Okay. Okay. Fine. Now I have one question which combines everything. Well, not this one. ये पहले solve करेंगे. There was a question in IISc Aptitude Test 2024 similar to this question. Problem type. The integral 1 to 2 e raised to x into x raised to x into 2 plus ln x dx equals e into 4e plus 1, 4e squared minus 1, e into 4e minus 1, e into 2e minus 1. This question also combines many things. Firstly, it combines, it uses logarithmic differentiation. Secondly, it makes use of the fact that if you have something of this kind, ये अभी आंसर में आया था, substitute करने के बाद ऐसे होता है वो, f of x plus f dash of x, okay, dx is e raised to x f of x plus c. Okay, so first of all, what we have to think or recognize is the fact that e raised to x is lying here, so it could be compared with this. Okay, luckily we've also got a function inside which contains two terms, so possibly we may be able to write it in this form. And also there is no chance that you are going to integrate it by parts or by substitution. Okay, so we now go for differentiating x raised to x and see if we can accommodate it inside. Okay, take log, take derivative, okay, we want dz by dx, remember, bring z there, x raised to x into ln x plus 1. So we have got our answer now. Okay, as in we have got what we want. What we can do is we can absorb that x raised to x inside. Okay, so it will be 2 times x raised to x, उसमें से एक x raised to x इधर लिखो, एक x raised to x इधर लिखो. Okay, so and plus x raised to x ln x. I've not done anything different. All I have done is I have taken this inside, and for this too I have written it as x raised to x plus x raised to x. है ना? Okay. Now last step. Okay. This x raised to x we can take common and add it as 1 plus ln x. Okay, and now if we call this as f, which one? This. If we call this function as f, let me zoom out a bit. Yeah, if we call that as f, then this becomes f dash. This whole thing becomes f dash. है ना? So finally it becomes e raised to x into x raised to x integral 1 to 2, and then you can very easily compute it. Yes, can you do that? 4e squared minus e. 4e.
Sir,
हाँ बोलो.
this is also in one way parts rule ना?
हाँ कर सकते हो सही पार्ट्स में ही है वो, लेकिन कैसे
Because
करोगे?
yes sir, because derivative of RHS of that logarithmic differentiation is basically LHS. So it's also reverse of parts rule, reverse of product rule in differentiation.
Yes. Basis तो पार्ट्स ही है, but the thing is there is no need to go back to original form, है ना?
Yes, so we have to recognize.
हाँ, recognize कर.
There the main role is differentiation. Yes sir.
Yes.
Yes.
ठीक है. Now I want to take one problem which will cover everything. It will cover functions, it will cover integrals, it will cover derivatives, it will cover graphs also. So let's take that and then we'll stop. मी तुला एक 5 मिनिटात करतो. हां सॉरी. Okay, one last problem. Okay. This is also from Nest. I forgot to put the year. Let f of x be e raised to minus 1 upon x squared plus integral 0 to pi x by 2 root of 1 plus sine t dt. X belongs to the open interval 0 to infinity, so x is not negative. Then f dash of x exists and is continuous. B. F double dash exists for all x. C. F dash is bounded. D. There exists alpha greater than 0 such that magnitude of f of x is greater than magnitude of f dash of x for every x in the open interval alpha to infinity. This is a multiple select question, meaning we must check for each and every option. Okay. Now please tell me how you think you can solve this particular problem. Let us start with option A. Is there any way to find f dash of x? Please tell me.
Use Leibniz rule.
Yeah, Leibniz rule, correct. Just 1 second. Well, due to that call, my meet got disconnected. Yeah, okay. So yes, please tell me what will be f dash of x. It would be e raised to minus 1 upon x squared into minus 1 तो आएगा minus 2 by x cubed plus what will be the derivative of the second term? Anyone? Root of 1 plus
90
sine pi x by 2 into pi by 2. Now, if you people remember, there are actually 2 more terms in that Leibniz rule. Okay? There are 2 more terms in the Leibniz rule. Right? And what are they? The first term being we take the derivative of this with respect to x, which is 0 because it doesn't have any x term there. And secondly, we also take the derivative of this, which is constant, so 0, so nahi likhte. ठीक है. Now please tell me, is this function continuous? Rather, does this function exist for all x in open interval 0 to infinity? Please tell me. Let us rewrite this. Okay, let us rewrite this. 2 into 2 by e raised to 1 upon x squared into x cube plus pi by 2 root 1 plus sine of pi x squared. Yes. First tell me, is it defined for all x?
No sir, a square root will become imaginary for some sign values.
कौन सा?
Sign.
See, it will be defined for all because look, for x 1 upon x cube to be defined, x should not be 0, but we are excluding 0. तो ये तो defined है ना? Right? And it is also non-zero. So denominator का वो issue sorted है. How about this one? First of all, we know exponential function never becomes 0. And then because x is not equal to 0, this is also very well defined and continuous for all x in 0 to infinity open interval. है ना? Okay, now come to this root part. What do you think will be the smallest number which will sit inside the root?
0.
0.
0.
Exactly. So there is also no question of this being undefined or being discontinuous here. Okay. So can we say that option A is correct? Yes, f dash of x exists and it is continuous. So option A is correct. Okay, option A is correct. Go to option B. Acha, okay, wait. Let us also go to option C now. Okay, let us also go to option C. What do you think can we say about option C? Is it bounded? As in, can we find out a real number and say that f dash of x always remains less than that?
No, sir.
No? Why?
So because x cube will have values that will be very great, way greater than any real number that we can define.
It will be bounded, sir. Sir, it will be bounded.
नहीं
Because
वो मुझे यस नो मत बता, उसका एक्सप्लेनेशन चाहिए ना.
yes, sir.
So I just realized I didn't consider e raised to 1 by
Exponential,
x
हाँ.
square, so I'll have to
Yes, look here now.
rethink.
Yes, correct. Look here. First of all, let's go for the limit of this function. See, I think you people would agree that f dash of x would always be less than 2 upon e raised to 1 upon x squared into x cube plus pi. Plus pi by, plus pi by 2 into root 2 into root 2, because the largest value that this can have is pi by root 2, right? 1 plus 1 2 root 2. So it then boils down to the question of deciding what happens to the values of 2 upon e raised to 1 upon x squared into x cube. Okay, and we have to take two limits here. First is we must take the limit as x tends to infinity of this. Okay, x tends to infinity of this. Now what do you think you can do to solve this problem? How to take the limits or how to find this limit? Tell me, कैसे निकालोगे इसका लिमिट?
सर 0 होगा.
0 होगा. कैसे 0 होगा?
Sir, denominator will become very large.
Denominator will become very large. Do others agree with what he is saying?
Yes, sir.
ये तो बड़ा होगा. Denominator, wait. X squared is large, so 1 upon x squared will go to 0, so this will go to 1. No? Yeah, so this is 0. Okay. Now let's also investigate for x tends to 0. वो भी करना चाहिए, क्योंकि बीच में तो कंटिन्यूस है, तो इंटरमीडिएट वैल्यू थ्योरम से काम हो जाएगा. Yeah, what do you think you can do to solve this problem? This limit, my suggestion is change the variable. Change 1 upon x to y. X tends to 0 from right, y tends to infinity. So this problem will then become e raised to y into यहाँ पे y cube आएगा. Now look, the property of exponential function is that it will always going to dominate. Okay, it will always suppress the behavior of polynomials. So this limit will also be equal to 0. निकाल सकते हैं, L hospital से भी हो जाएगा वो. Okay, also obtainable from L hospital.
Yes, sir.
Also obtainable from L hospital, but 0 तो bounded है, क्योंकि continuous भी है, तो intermediate value theorem will be applicable. End limits are 0, so this is bounded also. Okay, so A भी सही है, C भी सही है. ठीक है, A is right, C is also right. Let's go to B now. B says f double dash exists for all x. I am saying it doesn't. Please give me an explanation. I am saying f double dash of x does not exist for all x. Please give me an explanation.
So we'll have to find that f double dash x, and then we can draw some conclusion from the function f double dash x.
Exactly, you can. You have to. But just by looking at f dash of x's expression, can you come up with something? Just by looking at the expression for f dash of x, can we say anything here? I don't see any problem with this. Okay, find it. इसका देखो अभी 1/2 root x. Okay, 1/2 root x into f dash of x. Okay, now I am recommending you to take the value of x as कौन सा ले सकते हैं वैल्यू x का?
2 sir, x equals to cos pi is equal to 0.
नहीं 2 नहीं देना है. हाँ यार, I just thought you can take x equal to 3, but there the denominator is undefined, but numerator is also going to 0 there. Yeah, suppose we take x equal to 3. Yes, f double dash of x becomes indeterminate. है ना, 0/0 हो जाएगा वो. लिमिट निकाल के कुछ फ़ायदा नहीं है, because of this being 0 and this being 0. Yes, so options B is not right. Okay, we'll stop here. We're running out of time.
So just by looking at the expression for f dash of x, I think we can conclude that it won't be continuous.
Which one?
Did we conclude that it is continuous in option A?
Yes, because जो x cube denominator में है ना, वो 0 नहीं ले रहा है ना.
So I'm a bit doubtful about the second expression. I haven't solved it, but I'm a little doubtful about the expression in the under root.
This one?
Yes.
Why? What's the issue there? I don't see any problem there. Okay, fine. We'll stop here for today. Option D, we will either I will send you the solution for this one. थोड़ा tricky है वो. Okay, थोड़ा tricky है वो. Try it. I'll send you the solution. Okay. Now, those of you who have joined today, so what I'll do is